Welcome to the documentation for the 3D Render by KIRI Engine add-on for Blender. The add-on lets you import, edit, animate, and render Gaussian splat objects directly in Blender. We'll cover everything from basic setup to advanced features. For best results, we recommend watching the full documentation. However, if you're short on time, we'll start with the most important notes and a quick guide to get you up and running. The add-on zip file is named DGS Render, not 3D Render. This is deliberate. Don't rename the zip file or the add-on won't install properly and may cause errors. Imported 3D objects are often composed of millions of faces. These faces need to be updated to the camera view to render correctly. A very specific workflow will improve performance and visual quality massively. Now here's a quick guide to get from a PLY file to a finished render. Optimizing your PLY file improves performance speed down the line. This step's optional, but I'm going to first use the Import Edit Point Cloud menu to import my PLY as a point cloud. I can use Blender's native editing tools and add the Point Edit modifier to remove any unnecessary points. I'm only going to point the camera in one direction, so I'll delete half the points that I won't see, and re-export this edited PLY file. I'll re-import my edited PLY using the Import 3D menu. Updates are disabled for the object on importing so that it can be scaled, transformed, and rotated without performance considerations. I add a camera into my scene and move my 3D object so it is visible in the camera view. I enable camera updates for the object. I enable Use Active Camera for the object, which will permanently force all faces to point towards the scene's active camera. From the Modify Edit menu, I enable the Camera Cull modifier. The settings for the Camera Cull modifier need to match your active camera and your scene. Pressing Auto Setup will match the modifier's settings to the current settings for the camera and scene. While looking through the camera, Camera to View from the N panel View tab can be enabled. This allows you to navigate around the 3D viewport with the 3D object and camera culling modifier updating automatically. If you're not going to move the camera, or you're moving the camera along a single axis for your renders, you can apply the 3D modifier. Whenever possible, you should remove as many faces and apply as many modifiers as possible to your object. This will improve performance massively. To get the greatest speed boosts and visual quality, you should use the full range of modifiers available, which we'll cover later in the documentation. Okay, now let's dive into the full documentation. Installation. The add-on was made for Blender 4.2 and above. The add-on will not work with previous versions of Blender. To install the add-on, make sure you have downloaded the zip file DGS Render by KIRI Engine. Do not rename the zip file to 3DGS. The missing 3 from the zip file name is intentional. Renaming the zip file can break the add-on. If you're updating the add-on, make sure to uninstall any old versions and then restart Blender. In Blender, navigate to Edit, Preferences, and from the small drop-down arrow, select Install from Disk. Select the add-on zip and hit Install. The add-on can now be found in the 3D viewport. Pressing the N key will bring up the N panel where you can find the add-on. The add-on works with the Eevee render engine. If you have another render engine enabled, Cycles or Workbench, you will first be prompted to switch to Eevee. Once Eevee is enabled, you will see the full add-on interface. Preferences. The add-on preferences will show 3D.js import settings and allow the use of the HQ render function. These settings are covered fully in their dedicated sections, Import 3D.js and HQ render. Interface overview. The add-on interface is split into 3 sections. We will look at each section individually in greater detail later. The scene section. Buttons and settings here will affect all 3D.js objects in the scene. The active object section. Buttons and settings here will affect only the active object. The active mode. This menu is dynamic and can be changed depending on what task you are currently trying to perform. A full workflow from a PLY file to a finished render can be performed by going from top to bottom. The scene menu. For your objects to appear correctly, each face of the model needs to look at your current view. In this documentation, whenever we mention objects being updated or camera updates, we are referring to faces being updated to look at the camera view. Updates for all enabled 3D.js objects in your scene can be forced by toggling Start Camera Update on or off. For the scene camera updates, there are 2 modes, continuous and frame change. Continuous will attempt to rotate the faces as often as possible with no delay. This can be very performance heavy. Frame change will rotate the faces every time the frame changes on your timeline. This means you can control the updates by moving frames with the left and right keys. Update all to view will update all enabled objects in the scene once to the current view. Active object menu. Updates can be controlled individually for each object. Immediately after importing, updates for an object are set to disabled. Object updates can be enabled, disabled, or the object can be shown as a point cloud. When moving 3D.js objects around in the scene, it is recommended to disable updates or show as a point cloud to lighten performance requirements. If Enable Camera Updates is selected, 2 new options will be available: Update Active to View and Use Active Camera. Update Active to View will update only the active 3D.js object, not the whole scene, to the current view. Use Active Camera will automatically make the active 3D.js object continually face towards the scene's active camera. This option will only be available if there is an active camera in the scene. Pressing Apply Modifiers will bring up a new menu that will show all currently applied 3D.js modifiers for the active object. Using the checkboxes and OK will apply the selected modifiers for the active object. If you know you're not going to update a 3D.js object again, if it's a background element or used in a static camera shot, or your camera moves are linear along a single axis, you can apply the 3D.js render modifier. This will massively increase performance, but it does mean that the object can no longer be updated. Import 3D.js. On this menu, only one button is shown: Import PLY as splats. After pressing this button, you can choose a PLY file to import. Depending on the size of your scan and your computer's specs, you may need to wait a few minutes for the import to be complete. All import settings are kept in the add-ons preferences, so you only need to set them once or don't set them at all. In Preferences, we can see Auto Rotate for Blender Axes. Blender uses a different world axis than many game engines or 3D scanning solutions. Enabling Auto Rotate will rotate the model on importing to try and match Blender's world axis. Default face alignment will change what direction the object's faces are pointing to when you enter edit mode. Import Edit Point Cloud. This part of your workflow is optional, but can be useful for quickly removing unwanted points or isolating a single part of your 3D scan. Anything you can do to remove unwanted points or make your file smaller will help performance in the long term. Using import PLY as points will let you choose your PLY file and import it as a point cloud. You're free to scale, rotate, and move your point cloud while working. However, don't apply transforms. Applying scale or rotation transforms can mess up the Gaussian splat data. The Export Points for 3DGS button will revert all scale and rotation transforms before exporting. Hitting Append Point Edit Modifier will add a modifier to the point cloud that will allow you to see each point's color and also add a number of tools that can be useful for editing. Add Wire Sphere or Cube will add a non-renderable object to the scene. These objects can be useful to specify as crop boxes. Auto Crop BG Sphere will attempt to automatically remove the sphere of points that is often included in a 3DGS scan. If the points are not immediately removed, adjust the sphere threshold. Enable Crop allows you to specify a crop object and a method of cropping. Points can be removed inside, outside, or by distance to the crop object. If the cropping edits are not updating, hit the refresh button. Remove Isolated Points will remove points that have no close neighbors. The distance to a closest neighbor to be considered for deletion is set with the distance threshold. Color Edit allows you to remove points according to a selection color. Points can be removed if their own color is equal to, not equal to, darker than, or brighter than the selection color. Decimate will remove a percentage of the total number of points, from 0 to 100. The Decimate Seed will change which points are removed. When you're happy with your edits, you can re-export the edited point cloud as a PLY file using Export Points for 3DGS. Modify, Edit. The modifiers on this menu are all designed to reduce the number of faces in your 3DGS object, increasing performance. For an optimal workflow, it's advised to go through each modifier one by one, adjusting settings to meet your visual needs. Then, apply each modifier in turn to maximize performance gains. Add Wire Sphere or Cube will add a non-renderable object to the scene that can be used to affect modifiers. Camera culling is the most important modifier in terms of performance and usability. The modifier will remove faces outside of the camera bounds and by distance to the camera. An active camera is required to use the modifier. If the modifier is enabled and no active camera is present, a warning will show. The modifier's settings must match the active camera and scene settings. You can set this up quickly by hitting the Auto Setup button. The distance between the camera bounds and deleted faces is controlled with padding. It is recommended not to set this at 0 to avoid flickers when moving the camera. Faces can be deleted by distance to the camera using the closer than and further than values. Decimate will remove a percentage of the total number of faces from 0 to 100. The decimate seed will change which faces are removed. It can be useful to use a high decimate number while working to improve performance, then drop this number during rendering. Removing any number of faces is helpful, so a low number like 5% can be used and the modifier applied to improve performance. Crop box allows you to specify a crop object or collection and a method of cropping. Faces inside, outside, or by distance to the crop object can be removed. Color edit allows you to remove faces according to their color. A color selection and a removal method can be set. Faces can be removed if their color is equal to, not equal to, darker than, or brighter than the selection color. The selection can be controlled with hue, saturation, and value thresholds. However, due to Blender limitation, red values may be very difficult to select. Remove Stray will remove faces based on their size or edge length. Many times floating artifacts may have stretched faces compared to the rest of the faces in your object. So remove stretch faces will delete faces based on their edge length, which in many times can remove artifacts. Small faces may not be artifacts, but they may not contribute a lot to the overall visual quality. Removing these unnecessary faces and applying the modifier using remove small faces may improve performance. Shading. The shading menu allows you to easily edit your 3DGS objects materials. All 3DGS objects imported by the add-on share the same KIRI 3DGS render material. Changes to this material are global. If shadeless is enabled, the object will not react to the scene's lighting or world lighting. All colors will render flat as the lighting appeared when the object was scanned. If shadeless is disabled, BSDF settings for metallic, roughness, emission strength, and specular are shown. Because the object is composed of single flat faces, adjusting the BSDF shader will not give results comparable to a normal polygon mesh, but it can still be useful to fine-tune the material's look. Toggling base color adjustments shows options for manipulating the material's brightness, contrast, hue, and saturation. If white balance wasn't accurately set during scanning, you can adjust the white balance. With color masks, it's possible to target a specific color range within your object and replace that color with another color and a specific blend mode. After enabling show color masks, you can enable or disable up to 3 color masks. Inside each mask, you can specify a color selection and a color to change it to. You can dial in these color changes with the replacement method and the mix factor. Create extra attributes is useful for advanced users. We'll cover using attributes a little in the next section, but for now, know that creating extra attributes adds extra performance considerations to your object, so it is disabled by default. 3DGS material and attributes. Advanced users can manipulate the global KIRI 3DGS render material directly within the shader editor. Along with the shader node group, several other useful attributes and node groups are already present. The alpha edits group will let you modify the alpha values for faces for some very stylized looks. If create extra attributes is enabled in the shader menu, a face area and a random per face attribute can be used. If the animate modifier is enabled, is animated, and effector distance attributes are available. If the animate modifier is enabled and the 2 points preset is used, the point info node can be very useful. Modify, animate. The Animate modifier comes preloaded with presets and settings to quickly create stylized motion graphic renders using your 3D.js objects. As updating faces is already a highly performance-intensive task, it's extremely recommended that you use and apply as many modifiers as you can to reduce your face counts, work on an isolated object or separate your focus from the full scene, use the Decimate Animated slider to reduce the number of faces affected by the animation. Animation effects can be global, applied to the whole object, or by distance to a selected object or collection that we'll also refer to as effectors. If effect by object or effect by collection is chosen, a distance threshold will appear, and anything below this will be animated. There are 3 modes of animation: displace only, to points, and to curves. Each mode supports some of the following effects. Noise displacement displaces faces based on the standard blended noise texture. This is available in all animation nodes. You can control the noise strength, the noise scale, and you can make the noise evolve with your timeline by changing the value in the time evolution multiplier. This can be quite performance intensive, so it is set to 0 by default. Voronoi displacement will displace faces in the same way as noise displacement, but using the Blender Voronoi noise texture. Similar controls are available for the strength, scale, and time evolution multiplier. Pixelate will snap points of each face to Blender's world grid, forming a pixelated grid pattern. This is available in all animation modes. There are controls for the pixelate mix, which controls the overall strength of the effect, and the grid scale, which will control the size of the squares. To points will turn all animated faces into points. All displacement and pixelate effects will contribute to the point positions. The To Curves preset will turn all animated faces into curves. All displacements and pixelation will contribute to the curve positions. Render. Rendering 3D.js objects with thousands or millions of faces and many other modifiers is a very performance-hungry task. So to make rendering a little faster and more reliable, we have the render menu. Using the render settings from this menu, rather than Blender's native F12, will set all enabled 3D.js objects to use the active camera and will render all images offline to boost performance. The current Blender output settings will be used for all renders. In the menu, some of these settings are shown. The view transform and look are available, since 3D.js objects are optimized for the standard view transform. Eevee samples are shown, as sometimes the default 64 samples can result in a grainy image, and it's recommended to use a higher number. The output format can be selected. You must use an image format to use the offline render. You can choose render offline image to render a single image, or render offline animation to render an animation using your current timeline settings. Because the render is performed offline, you will have to wait for the render to complete, or if you want to cancel the render, you will have to force close Blender. For this reason, it's usually best to test render a few frames of an animation to check all your settings before rendering a very long sequence. HQ Render. HQ Render is an alternate method of rendering that can, in some situations, give a much better quality than the standard render. HQ Render is not available for Linux systems, only Windows and Mac. HQ rendering is a very performance-intensive process and will take a long time. You should always test render a single frame before attempting to render an animation. By default, the HQ render menu will show a warning, specify sort file in preferences. For HQ rendering to be performed, the add-on needs to use some custom external sort files shipped with the add-on. Packaged with your add-on zip file, you should have a folder named 3dgs sort. Windows users need to look in the releases folder and find the 3dgs sort exe file. Mac users need to look in the Mac folder and find the sort file, not the C++ source file. When you have your files available, go to the preferences and specify the file in the source path. The full HQ render menu should now be shown. The menu is identical to the render menu. HQ renders do not support depth of field, and any dynamically changing modifiers such as camera culling or animation will not be respected. Omniview Object. If you are familiar with the concept of imposters in video games, this is a similar experimental approach. The standard 3dgs objects have one face per 3dgs point, and this face rotates to the current view. An Omniview object has multiple faces per point. Each face is static, does not rotate, and faces permanently aligned to a specific axis. These objects don't need updating and can be instanced, making some performance-heavy tasks much lighter. To create an Omniview object, you must first select a 3dgs object that has the 3dgs render modifier attached. Once selected, the menu will let you select how many axes the generated object should be aligned to. 3 axes would create 3 faces for each point. 9 axes, 9 faces for each point. So it's best recommended to create Omniview objects from isolated objects, not full 3dgs scenes. Hitting Create Omniview Object will create a new object offset from your original, and all modifiers will be removed for this object. If an Omniview object is selected, a new option will be shown in the shader menu, the View Angle Threshold. This is a value in degrees and will determine at how many degrees the current view can deviate from before a face disappears. If a value is set to 1, the face would only appear when looking directly at it. If the value is set to 360, the face will always be visible. This can be a useful way to blend between the different axes of each face in the Omniview object. Because this feature is very experimental and not a standard method of rendering Gaussian splats, it may sometimes crash or freeze Blender. Resources. If you ever want to revisit this video documentation or open the written documentation, you can press the Documentation or Tutorial video buttons from within the add-on. If you're interested in using more of our add-ons, the See All Add-ons on Blender Market button will open a web browser with our add-ons marketplace. If you have any questions, want more help, or just want a warm community of Blender users and 3D scanners, consider joining our Discord. Links in the description. If you want to make your own Gaussian splat scenes, use the KIRI Engine app. Or if you want to download some free, high-quality examples, each week we update our free library of photo-scanned and Gaussian splat downloads.